Okay guys, we got our study guide for forces and motions, motion in one direction. We'll start here with the definitions. So the first one is physics, so that's simply the study of matter and energy. We have resultant, you can either say start to finish, origin to end point, beginning to end. All these things work. Component is the x and y part of any vector. Vector, magnitude and direction. Scalar, magnitude. Head to tail addition, probably the best way is just to draw a picture showing two vectors, placing one vector on the head of the other one, placing the tail on the head of the other, and getting the resultant. Projectile, it's an object launched at an angle. Sometimes the angle is 0, only affected by gravity. Trajectory, that's the path of the projectile. Equilibrium, net force equals 0. Range is the distance in the x traveled by the projectile. Distance in x traveled by projectile. So these are our definitions. Let's start looking at some of the conceptual now. So for the conceptual, first one deals with parabolic motion. Zoom out here a bit. It says draw in the velocity vectors for both types of parabolic motion. Ball shot horizontally off a cliff and ball shot up in the air at some angle. So let's deal with the horizontally off a cliff first. So we launch it off the cliff and we get the half parabola. The thing you want to remember is that the x stays constant while the y grows in shape and size. And we end up with the overall larger velocity when it lands, or the resultant. Something launched at an angle looks more like this. So once again, the x stays the same all the way through, while the y changes. So at the beginning there might be a lot of y, less, apex none, start going back down, increasing in y. What's kind of weird is that whatever v we start with is the same that we land with. So whatever we started with is equal to what we land with, as long as they're at the same height. So now we put in the vectors. It says describe how the x and y velocity and accelerations differ. The x velocity is constant. The y velocity changes. However, the y acceleration is constant. Where because the x velocity is constant, the x acceleration equals 0. This is how I would compare them. Next, a hammer is dropped on the surface of Mars and falls with an acceleration of 3.7. No question there. Would the acceleration be smaller, larger, or the same if it was thrown horizontally at 10? The acceleration would be the same. It would still be 3.7. So it doesn't matter that we're on Mars. You know, if you have a hammer and you drop it, it's still gonna, accelerate at that rate 3.7. If we throw it horizontally, it's still gonna get to the ground at the same time. It doesn't really matter whether that we're on Mars. Same as on Earth. Drop bullet, fired bullet, hits the ground at the same time. So it doesn't matter it was thrown horizontally at 10. Go back up here to this example. If we look at how the dots separate, the distance in the y is the same for both of these at the same times, meaning a dropped object and a shot object hit the ground at the same time. What angle should a projectile be launched in order for it to get max height and max range? Max range, that would be 45 degree. So it's going to do something like that. It's going to get equal x and y components for the greatest range. Max height would be 90, although its range would be 0. So if you have all y component, it goes the highest. How far below an initial straight line path will a projectile fall in 1 second? So the distance below the straight line path is always equal to 1/2 gt squared. So that's, it's falling at a rate of gravity, and this is how the distance is affected by gravity. Goes back to magic physics formula number 3. Does your angle depend on the angle, or does your answer depend on the angle or the initial speed of the projectile? No, it doesn't. You could launch at a higher angle. Here'd be my straight line path then. You can see we still deviate by 1/2 gt squared. Now if you fire it with weak speed, it's still going to deviate from the straight line path at 1/2 gt squared. So it doesn't matter the initial speed, or it doesn't matter the initial angle, it still deviates from the straight line path at 1/2 gt squared. So if a hunter is attempting to shoot a monkey out of a tree, and the second he pulls the trigger, where should he aim? If there's a monkey right here in the tree, and the monkey lets go of the tree, he's still going to fall at that same rate, 1/2 gt squared, and the monkey will die. So you want to aim for the monkey, not above, below, but at the monkey. So you want to aim at the monkey. Okay, so that's parabolic motion. Let's take a look at the next one, which is forces in 2 directions. So what shape is needed to add vectors in 2 directions? So we need a right triangle. So if you have components, or you form some x and some y, x and y are always 90 degrees from each other, so you always end up with a right triangle. Define equilibrium. Equilibrium is defined as when the net force equals 0, or balanced forces. When a right triangle is made with the y-axis is x cosine or sine. So if we make it with the y-axis, the opposite side would be the x side. Therefore, x is sine and y is cosine. And typically we don't measure angles with the y-axis. Typically we measure angles with the x-axis. So this is kind of different than it normally is. When pulling an object at an angle, why is the Fn decreased? So when you pull with an angle, you lift up on the object, meaning it has a y component. Therefore, if we had a certain amount of weight, that weight would be reduced by whatever this y component is, maybe by that much, so that the up arrow is only the top part of this. So this plus this equals that. So the force of normal gives you what you need, and when you lift up, you need less. Write an equation to solve for the acceleration of an object on an inclined frictionless plane. So if we have a 0 friction plane, if we look at our forces, we'd have Fmg down, a reduced Fn up. Then this weight would have 2 components. If we turn our coordinate system so the acceleration lines up with the inclined plane, I would have a y component and an x component. So the x component would be Fmg, this is opposite, so sine of theta, this interior angle is the same as the inclination of the inclined plane, equals ma. F just tells us we're dealing with a force. In terms of mass, in terms of what actually matters is the mg, so we cancel out m on both sides, we're left with g sine theta. So g sine theta is how we figure out the acceleration on an inclined frictionless plane. If an object is hung at 2 unequal angles, which one has the greater tension? So if we have a sine and one angle looks like that and another angle looks like this, if you look at their angles, the greater angle with the x-axis will have less tension. So shorter strings result in less tension. So this Ft would be, no, that's not right. The shorter string would have greater tension. So this one would have a lot of tension, and this one would have a little bit of tension. So the FT on the shorter string would have greater tension. It's because their X components are equal, and if we look at their Y components, they won't be the same, but their X components are the same. That's because it's not moving left or right. These two things added together will be equal to the weight. You can find a relationship by comparing the X components and then subbing that relationship into the Y. But if you just remember that the shorter string has greater tension, then you'll remember the rule of thumb for this. And that's pretty much it for the conceptual. So we'll take a look at the math here in the next video.